Hello friends, welcome back to the CSC guy. This is our first lecture of we discussing our first chapter in distributed databases. So first, let us explain the concept of distributed data processing. What is distributed data processing? Distributed data processing is a computing paradigm that involves processing large amounts of data by breaking it down into smaller chunks and distributing them across multiple machines or nodes in a network. This approach enables the process of massive data sets that would be too large or complex for a single machine to handle. Now let us discuss some key characteristics of distributed data processing. First is decentralized architecture. The data is split into smaller chunks and processed in parallel across multiple machines, reducing the load on individual nodes. Next is scalability. Distributed systems can handle large volumes of data by adding more nodes to the network as needed. Next is fault tolerance. If one node fails, the system can continue to operate and the failed node can be replaced or recovered without significant disruption. Next, let us see how this all works. First is data ingestion. Large data sets are collected and split into smaller chunks called data blocks or splits. Next is data distribution. Data blocks are distributed across multiple nodes in the network, which can be located in different geographical locations. Next is processing. Each node processes its assigned data block in parallel using a processing framework such as MapReduce or Spark. Next is data aggregation. Processed data is aggregated from each node and combined to produce the final output. Next, let us see some benefits. First is improved performance. Distributed processing enables faster processing times for large data sets. Next is increased scalability. Distributed systems can handle growing data sets by adding more nodes. Next is enhanced reliability. Fault tolerant design ensures minimal disruption in case of node failure. Next, let us see some common applications. First is big data analytics. Distributed processing is used in big data analytics to process large data sets from various sources. Next is machine learning. Distributed processing is used in machine learning to train models on large data sets. Next is scientific computing. Distributed processing is used in scientific computing to simulate complex systems and process large data sets. Next, let us see some challenges and limitations. First is complexity. Distributed systems can be complex to set up and manage. Next is communication overhead. Communication between nodes can reduce latency and overhead. Next is data consistency. Ensuring data consistency across nodes can be challenging. In summary, distributed data processing is a powerful paradigm for processing large datasets by breaking them down into smaller chunks and distributing them across multiple machines. While it offers many benefits, it also presents challenges and limitations that must be carefully managed. Next, let us analyze the challenges associated with distributed data processing. While distributed data processing offers numerous benefits, it also presents several challenges that must be carefully managed to ensure efficient and effective processing of large datasets. Here are some of the key challenges associated with distributed data processing. First is complexity. Distributed systems can be complex to set up and manage, requiring significant expertise in distributed computing, networking, and data processing. The complexity of distributed systems can lead to steep learning curve. Distributed systems require a deep understanding of distributed computing concepts, data processing frameworks, and networking protocols. Next is difficulty in debugging. Debugging issues in distributed system can be challenging due to complexity of the system and the difficulty in reproducing errors. Second challenge will be communication overhead. Communication between nodes in a distributed system can introduce latency and overhead, which can significantly impact performance. The communication overhead can be attributed to network latency, And serialization and deserialization. What is network latency? Data transfer between nodes can be slow due to network latency, which can impact the overall performance of the system. Now, what is serialization and deserialization? Data needs to be serialized and deserialized when transferred between nodes, which can introduce additional overhead. Next challenge will be data consistency. Ensuring data consistency across nodes in a distributed system can be challenging. Data consistency issues can arise due to data replication, network partitions. What is data replication? Data replication can lead to inconsistencies if not managed properly. How network partitions? Network partitions can cause data inconsistencies if not handled correctly. Fourth challenge will be scalability. While distributed systems are designed to scale, scalability can be a challenge if not planned properly. Scalability issues can arise due to load balancing. How load balancing? Load balancing can be challenging in distributed systems, especially when dealing with uneven data distribution. Next will be resource allocation. Resource allocation can be challenging in distributed systems, especially when dealing with limited resources. Next challenge will be fault tolerance. Fault tolerance is critical in distributed systems, but it can be challenging to achieve. Fault tolerance issues can arise due to node failures. Node failures can impact the overall performance of the system if not handled properly. Network failures. Network failures can impact the overall performance of the system if not handled properly. Next challenge will be security. Security is a critical concern in distributed systems, but it can be challenging to ensure. Security issues can arise due to data encryption, especially when dealing with large data sets. Next issue will be access control. Access control when dealing with multiple users and roles. Next challenge will be data locality. Data locality can be a challenge in distributed systems, especially when dealing with large data sets. Data locality issues can arise due to data distribution, especially when dealing with uneven data distribution. And another issue is data access patterns, especially when dealing with sequential data access. In summary, distributed data processing presents several challenges that must be carefully managed to ensure efficient and effective processing of large datasets. By understanding these challenges, developers and administrators can design and implement distributed systems that are scalable, fault tolerant, and secure. Now let us define distributed database system. How does it differ from a centralized database system? And let us also discuss the key components and characteristics of distributed database system. First, what is distributed database system? It is a database that is spread across multiple physical locations connected by communication links. It is a collection of multiple logically related databases that are distributed over a network of interconnected computers. Each site in the network can have its own processor, memory, and storage devices, and the data is distributed among the sites. Now, what are the key differences from centralized database system? How is distributed database system different from centralized database system? First is data distribution. In centralized database system, all the data is stored in a single location, whereas in a distributed database system, the data is distributed across multiple locations. Second is processing. In a centralized database system, all the processing is done at a single location, whereas in a distributed database system, the processing is distributed across multiple locations. Third is control. In a centralized database system, the control is centralized, whereas in a distributed database system, the control is distributed among the sites. Now let us see some key components of a distributed database system. Distributed database management system. The distributed database management system is the software that manages the distributed database. It provides a layer of abstraction between the user and the physical database. allowing the user to access the data without knowing the physical location of the data. Next is nodes. The nodes are the individual computers that make up the distributed database system. Each node can have its own processor, memory, and storage devices. Third component is communication links. Communication links are the connection between the nodes that allow them to communicate with each other. Fourth component will be data. The data is the information that is stored in the distributed database system. Now let us see some characteristics of distributed database system. First will be distribution. The data is distributed across multiple locations. Second will be autonomy. Each node in the distributed database system has a degree of autonomy, meaning that it can operate independently of the other nodes. Third will be communication. The nodes in the distributed database system communicate with each other through the communication links. Fourth will be reliability. The distributed database system is designed to be fault tolerant, meaning that it can continue to operate even if one or more nodes fail. Fifth will be scalability. The distributed database system can be scaled up or down as needed by adding or removing nodes. Now, let us see some advantages of distributed database system. Improved performance. The distributed database system can provide improved performance by allowing multiple nodes to process data in parallel. Increased reliability. The distributed database system can provide increased reliability by allowing the system to contribute to operate even if one or more node fails. Enhanced scalability. The distributed database system can be scaled up or down as needed by adding or removing nodes. Better data localization. The distributed database system can provide better data localization by allowing data to be stored closer to the users who need it. Let us see some disadvantages of distributed database system. First will be complexity. The distributed database system can be more complex to design and implement when when compared with centralized database system. Second will be higher cost. The distributed database system can be more expensive to implement and maintain than a centralized database system. Third will be data consistency. The distributed database system can have data consistency problems if the data is not properly synchronized across the nodes. In summary, a distributed database system is a database that is spread across multiple physical locations connected by communication links. It provides improved performance, increased reliability, enhanced scalability, and a better localization, but can be more complex and expensive to implement and maintain than a centralized database system. Now let us see some important points. Let us define distributed database system. A distributed database system is a database that is spread across multiple physical locations connected by communication links, allowing data to be stored and processed in a decentralized manner. Now let us define distributed computing system. A distributed computing system is a network of interconnected computers that work together to achieve a common goal, sharing resources and coordinating their actions to process and manage data in a decentralized and concurrent manner. Next, what is parallel database system? A parallel database system is a database system that uses multiple processes or nodes to process multiple parts of a query or task simultaneously, improving performance and improving performance and speed by dividing the workload across multiple processing units. Next, what is the main characteristics of pull-based delivery? Pull-based data delivery. In a pull-based data delivery system, the client requests data from the server and the server responds by sending the requested data, allowing the client to control when and what data is received. Next, what are the three alternative delivery modes for data? The three alternative delivery modes for data are pull-based recovery, push-based and pull-based delivery, push-based delivery, and event-driven. or publish subscribe delivery mode. Thank you.